Assalamualaikum. I'm Nurizati binti Osman 265001 and my partner name Muhammad Syami bin Zayanan 264493. Our research title is The Effectiveness of Vaccine Intervention Against COVID-19 among Malaysia citizens using System Dynamic Modelling. Our objectives our objective is to predict the number of active or affected COVID-19 cases after vaccination is conducted from May until October 2021. Second objective is to develop model to identify the effectiveness of vaccine in combating COVID-19. And lastly, objective to suggest possible intervention the effectiveness of vaccine at system dynamic modeling.
Alright, I want to present about methodology. System dynamics is a methodology for comprehending a system's behavior across time. The system modeling technique has been used to address dynamic issues in engineering, medicine, social science, and ecology. It has been used to simulate complicated systems in order to better understand how various phases react throughout time. Traditionally, system issues have been handled by examining the links between the causes and the consequences of individual system constituents. However, the causal interaction in many systems are complicated and may occur simultaneously as a consequence of and as a cause of another. To observe, analyze, and model systems holistically, a holistic modeling technique is required. The concept of system dynamics modeling best satisfies the aforementioned aims since it decomposes a system into several tiny independent elements, allowing the system to be analyzed holistically and consider causal links in a dynamic and multidimensional manner. The dynamics of a system is composed of feedback loops and variables such as stock, flow, and auxiliary. Feedback loops are shown in diagram showing causal linkage. At any given moment, stock refers to the status of an element of a system that influenced by the system's overall or partial pattern. Flow is the moment by which the value of stock grows or drops over a period of time. Auxiliary variables are those that affect the flow values over time by changing the stock. After defining and validating all causal links, stock, flow, and auxiliary variables, the system is simulated for an appropriate period using the starting baseline values of historical data. By comparing the simulation results of historical data, it is possible to verify whether the system dynamic model accurately depicts the system's true behavior. For more than 30 years, system dynamics has been employed as a comprehensive modeling and dynamic simulation technique in wide variety of fields. As a methodology that uses a system dynamic approach to assist people in making better decisions when faced with complex dynamic systems, the field offers a philosophy as well as tools for modeling and analyzing system dynamics. Moreover, the field provides techniques and tools for investigating current decision making and assisting decision makers in learning. The proposed model was developed using Vensim software. There are several steps in this methodology, which is identification of parameters, construction of closed-loop diagram, development of a stock and flow diagram, validation, and policy formulation. So the stock and flow diagram are algebraic representation of the model based on the discovered closed loops. This section discusses the application of each parameter in a stock and flow diagram. Figure 2 describes the stock and flow diagram. This is our stock and flow diagram. For our structured behavior, the units are OK and the model is OK when we're running it. Model validation, or the precision with which the model behavior reproduces the model structure, is an important phase in system dynamic modeling hierarchy. In terms of model validation, there are two sorts of modeling techniques, which is causal, descriptive, and black box. Model feedback loops are taken into account in causal descriptive model. On the other hand, only the whole input-output ratio is considered. In black box models, relationships are important, which make them data-driven. Both types of modeling methodologies have their advantages and disadvantages. Validity assessments are frequently conducted using statistical approach. This is our comparison, which is our historical data and our our current rate, which is estimate for prediction. Figure C intervention 1. For the hypothetical COVID-19 cases, the simulation shows an increase in the number of people from May until August. The first intervention reaches the number rate vaccinated into 0.468085, so we reduce the COVID-19 cases so as affect the death rate to decrease. For the second intervention, we cannot control from the normal rate vaccinated to recover. This is because when the number of cases COVID-19 decreases, the number of population decreases, the total number of people recovers also decreases.
This research paper of study to make the community aware that this vaccine is effective against COVID-19 for the population to save human life from the contagious disease. The first Therefore, two interventions are made to seek for model improvement. The first intervention represents the strategy where the number of vaccinated increase and the total number of COVID-19 cases increase. In second intervention, the number of people vaccinated must be increased to ensure the total number of COVID-19 cases decrease. In conclusion, the effectiveness of vaccine can be proved when there is reduction in COVID-19 cases. It is clear that the vaccine affects COVID-19 cases.